Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's say today's problem, course schedule. So what today's problem is saying is that we'll be given n tasks. We'll be given n tasks and one of the pair, right? So we'll be given n tasks and what they're saying is some tasks may have prerequisite tasks. For example, to pick task 0, you have to finish first task 1. So this is one of the pair, right? So what they're saying is in order to pick this task 0, you have to first finish this task 1 and then only we can pick up this task, 0 task. Okay. So this is a condition given. So given the total number of n tasks and a prerequisite pairs of size m, find the ordering of tasks. So we want to find the order of the task. So if you see this example, right? So these are the n tasks given and m pairs, right? M pairs are given. Okay, m pairs. Okay. So and what we want to do is we want to return the correct order of the task. So there can be multiple correct orders. So we have to return just one. Okay. So if you see here, here is the correct order of the task. There are two correct orders, 0, 1, 2, 3 and 0, 2, 1, 3. Okay. We need to return only one. Okay. And if we return one correct order, then that means output will be given from their side will be one. Okay. And if we return an empty array, that means the ordering is not possible. We cannot execute the task. There is a deadlock here. Okay. So there is a deadlock. So the driver code will print no ordering possible. Okay. So uh, so looking at this, right? So this is an application of graph problem. Okay. So this is an application of topological sort to be specific, topological sort or topological ordering. Okay. So see, let's see this example, right? So let's take this example. Okay. So what they are saying is, for example, right? So first pair is 1, 0. So what it says, so we need to, for this pair, right? We need to first finish task 0. Then only we can pick up task 1. Okay. So for example, how it will be? So, so it will be like this 1. Okay. So first we need to finish this task 0. Then only we can pick up this task. Okay. So there will be a directed graph from 0 to 1. Again, the second pair is 2, 0. That means we need to finish 0 first in order to execute task 2, right? So there will be a path from 0 to 2. Okay. Then we have another pair 3, 1, right? Another pair 3, 1, right? So what it says, we need to finish task 1 first, right? Then only we can finish task 3. So there will be a directed graph, directed edge from 1 to 3. Okay. Then we have another pair which says we need to finish 2 before 3. So we'll have another edge from 2 to 3. Okay. So we have a graph here. Okay. We have this graph over here. Okay. So now what we'll do is we'll create an adjacency list. Okay. The representation of the graph, right? So it will be like 0, 1, 2, 3. Okay. So what it says is, okay. So we'll create this adjacency list, right? So this 0 will have path from, is having path from 0 to 1 and 0 to 2. 1 is having path to 3, right? 2 is having path to 3 and 3, it is not having any path. Okay. So what we'll do is now, once we create this adjacency list, right? Once we create this adjacency list, we'll have an in degree array. Okay. So let's have this. It will have, the size will be according to the number of nodes, right? Okay. So here, if you see what is in degree, basically, so in degree of a node will be the number of paths, right, to that node, the number of paths to that node. So the number of paths to this node is 1. So the in degree is 1. Okay. The number of paths to 2 is 1 only. So in degree is 1. So here the number of paths, right, to this 3 node is 2, right? There are 2 paths, right? So the in degree for 3 is 2. Okay. So we'll go through the adjacency list, right? And what we'll do is we will find the neighboring, right? For example, now we'll iterate through this 0, right? And we'll find the number of the neighbors, basically the neighbors. Okay. And what we'll do, so what is the neighbor of 0? The neighbor of 0 is 1 first. So we'll increment, right? So there's a path going from 0 to 1. That means that there's a path, that means there is in degree of 1 is 1. So what we'll do, in degree of 1 is, this is in degree add, right? In degree of 1 is 1. Again, the neighbor, right? There's a path from 0 to 2. So in degree of 2 is 1. Okay. Then we'll come here to this one, right? So there's a path from 1 to 3, right? So we'll increment the in degree of the neighbor, right? The neighbor. So neighbor is 3. So we are incrementing here 1. So we'll come here 2. There's a neighbor, right? So this pass from 2 to 3. So we'll take the neighbor and increase the in degree. So the in degree of 3 is 1. So we are going to increment and make it 2, right? 2, right? Because we have 2 paths from 3, right? And then 3 will be as is. Okay. So now we have our in degree array, right? So what is in degree array? 0, 1, 1, 2, right? 0, 1, 1, 2 we have. Now what we are going to do is we'll have a queue now. Okay. We'll have a queue. Okay. We'll take a queue now. And what we'll do, whichever nodes will iterate through this array, and whichever nodes in degree is 0, we are going to put that particular node. Okay, so in this case, in this example, so zero nodes in degree 0, right? There's no incoming path coming to 0. So we'll put in the queue. Okay, now what we are going to do is we are going to iterate through this queue, right? Until the queue is empty. Okay, so we are going to iterate through the queue, and what we'll do is, okay, so now let's have this right, this graph over here, right? So now we are going to iterate through the queue, right? Like while queue is not empty, right? For example, right, is not empty. So we are going to pick this, right? We are going to pick this node, right? And we'll have one topo list array or list, whatever it is, right? So what we're going to do is we are going to remove this queue, remove the 0 from the queue, right? And we are going to add in the topological array. Okay. And what we are going to do when we add this also, what we're going to do is we had this path, right? For example, now we had this, yeah, this, right? Like this we had. Okay. So what we did, we removed 0 from the queue, right? And we added in the topo, right? This topo array. And now what we are going to do is we are going to also have, so when we remove 0, right? So when we remove 0, so we have, what we have done is we have removed 0. So what we are going to do is we are going to, this is also removed, right? So we are going to decrement the in degree of both these nodes because we have removed 0 from the graph. We have removed 0 from the graph, right? Okay. So we are going to decrement. So there are no in degree, no incoming paths to 1 and 2, right? So we are going to decrement the neighbors of 0, the neighbors of 0. And what are the neighbors of 0? The neighbors of 0 are 1 and 2. Okay, are 1 and 2. Now, what we'll do is we'll go again to this in degree array. And whoever's node is nodes in degree 0, we're going to put in the queue. Now, if you see 1 and 2, right? They are both in degree are 0. So we are going to add in the queue. Okay, we are going to add in the queue. Okay. And similarly, now we'll remove this one from the queue, right? And we'll add here. We'll add here in the topo, right? And that means what we're doing is, right? What we're doing is we have removed one from the graph. We have removed one from the graph, right? So we are going to also decrement the in degree of the neighbor of one. So who's the neighbor of one? 3, right? So now we are going to decrement. Again, it is going to be from 2 to 1. It is going to be, right? Okay. And then what we are going to do, now we have done this, right? And after doing this operation, we don't have any currently any node whose in degree 0. Okay. So now what we are going to do, we are going to again, we'll check whether this queue is empty or not. And then we are going to remove 2 also, right? After removing 2, we have removed from the graph, right? After removing 2, what we are going to do? So we have removed from 2 from the graph. We'll add 2 here in the topo array, right? And then what we're going to do? We are going to reduce the in degree of 2's neighbor because we have removed 2, right? So we are going to remove or decrement the in degree of the neighbor. So who's the neighbor? 3 is the neighbor. So we are going to decrement. It will be 0 now, right? And then what we are going to do is we are going to add. So we'll check who's in degree, the nodes whose in degree is 0, we are going to add in the queue. So we have added in the queue, right? So now again we'll come here. Yes, the queue is not empty yet. So we'll remove 3, right, from the queue. We'll add in the topological array. And now we don't have anything for further processing, right? So we'll just add in this topological array. And now this time queue will be empty and will come out. And this is our output. Okay, this is our output. So I hope you have got, let's go to the solution quickly now. See here, first I'll demonstrate the Java code, right? And then C++ code. So here, this is adjacency list we are creating, right? So here nothing, we are just initializing each list in the adjacency list, right? We are initializing each list. We are taking the size of n. We are taking the size of n. N is nothing but the number of nodes. The number of nodes, V, that is 0, 1, 2, 3 in this example, right? That is, the number of nodes is 4. Okay. And then what we are doing is, see, what we are filling the adjacency list now. So what we are filling, we are creating a path from, so if this is the case, right? So what we are doing is we are creating a path here from 0 to 1. See, we are creating a path from 0 to 1. So 1, right? 1 means we are taking this particular element, 1, and then we are creating a path. We are then adding 1 to this particular 1, right? To this 0. Okay, so we are creating path here. And then here, what we are doing is we are iterating through the neighbors of this access list, right? We are iterating through the neighbor. Okay, neighbor, and what we are doing here, we are incrementing the in degree. Okay, we are incrementing the in degree here. Okay, so once done, incrementing the in degree, like we are calculating the in degree, and then we are having q. And initially, what we are doing is whichever nodes in degree is 0, right? We are adding in the queue. We are adding in the right. We are adding in the queue. Okay, and then what we are doing is we are now iterating through the queue, right? We are iterating through the queue, We are picking up the first element, remove the first element from the queue, adding to the topo sort. And then what we are doing is, as we have removed this node, particular node from the graph, right? So what we want to do is we want to decrement the in degrees of the node's neighbor, right? Of the node's neighbor. So we are decrementing. And whichever nodes in degree now is 0, we are going to add in the queue. And similarly, so we are going to process till queue is not empty. And then here we are checking if topo size, right? So here we have added topological, right? The nodes, right? If topo size is the number of nodes or number of tasks, basically the number of tasks, then nothing. We are just copying in the array, okay, and then returning. Else, if it is not, the size is not equal to the topo size is not equal to the number of tasks, we are returning an empty array. Okay, so this is a Java code, okay, and we have C++ code here as well, right? So vector, not much difference, right? Adjacency list, we'll have vector factor. Then we are creating the adjacency list here. Okay, we are calculating the in degree of every node. Okay, we are in the queue, we are adding those nodes whose in degree is 0, right? And then we are iterating through the queue, okay? And then we are popping out one by one nodes at a time and decrementing the in degree of the neighbors, right? And then finally, we are checking whether the topo size is equal to the number of tasks. That means it is possible, and we are returning the array. Else we are returning empty array. So yes, there's a solution. Let's submit it. Yes, so it is accepted. I hope you've got the solution. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.